All right, let's begin our discussion about vectors. All right, first of all, what is a vector? Well, we know a vector is a quantity that has both magnitude and direction. So let's draw a vector. We'll call this vector u. So you see it's pointing in a particular direction and it has a particular length. Now let's look at some of the features of this vector u. It has what we call an initial point, and that's where it starts, and we have a terminal point, and that's where it ends. All right, and the notation that we use, well, we use lots of different notation. If we have, if it's in text, then usually you will see a bold u to represent a vector. If we can't, sometimes we put an arrow over our letter to signify that it's a vector. But often, when the context is clear, we just write the u and know that we are talking about vectors. You have to be careful, though, when we introduce scalars. All right, we're going to talk about some operations on vectors, and the first of which will be the addition of vectors. So let's start with two vectors. Again, let's let this one be u and this one be v. So you see they're going in different directions and they have different magnitudes. All right, so to sum up two vectors, for example, we want to find the new vector u plus v. We take the tail of v and we place it at the head of u, and that's not quite right. Let's try that again. It needs to go in exactly the same direction as v and have exactly the same length. And this vector right here is equivalent to v. And then we sketch the new vector that's coming from the tail of u to the head of v, and that is u plus v. All right, what it is not, which often people make the mistake of doing, you don't take and place them tail to tail. So this u and v tail to tail does not represent u plus v. All right, so remember, if you want to sum u plus v, you're going to take the tail of v and place it at the head of u, and then you're going to construct the new vector from the tail of u to the head of v, and that's going to be u plus v. All right, so that's our vector addition. Now we're going to talk about scalar multiplication. So here we have to be really careful about notation, because we want to distinguish between just numbers, which we're calling scalars, and vectors, which have magnitude and direction. So we're going to let c be a scalar, and we're going to let u be our vector. Okay, so we're going to be really careful about signifying the difference here. So what is c times u? Well, that just means we're going to take our vector u and we're going to scale it by a factor of c. So, for example, if this is our vector u, then 2u, so my scalar here is 2, will point in the same direction as u, but go twice as far. So that is 2u. Similarly, 1/2 u will go in the same direction as u, but be half as long as u originally. All right? Now, one of the most important scalars to understand is when we take our vector, we multiply it by -1. So if this again is u, then -u is the same magnitude, but pointing in the opposite direction. Now, this is important for when we want to subtract vectors. What we're really going to be doing is adding negative vectors to each other. So if you remember, if I take the vector u, and let's let this be v, and I want to add them, I take the tail of v, place it at the head of u, goes in the same direction, and this resulting vector is u plus v. Well, what if I want to find u minus v? The first thing to note is that's really equal to u plus the opposite of v. So let's construct that picture. So here we have our u, and instead of v, which looks like this, the opposite of v, I'm going to erase this to make room. Let's move this out of the way. Okay, so the opposite of v, let's fix that, make that a little bit better. It's going to point in the same direction, the same magnitude, but the opposite direction. So that's going to be minus v. So to find the sum of u plus minus v, you're going to go from the tail of u to the head of minus v. So that is u minus v. Perfect. Now go practice.